Now, what are the advantages of the aluminum copper alloy? So high strength to the weight ratio, ideal for the aerospace and automobile application. What we are getting, the higher strength with having the low weight. So high strength to the weight ratio means that you are getting at a high, at a low weight, that you are getting a high strength. So your strength would be high at a very low weight, and that is very ideal for our aerospace, right? Though we are concerned for the automobile as well, but most of the time that if we talk about the weight, all the times we are concerned about the weight, okay? Because if weight is high, our running cost will be high, the fuel will be high, okay? Even on the road, if there, if your vehicle is more weighted, it means you need to you need to run more energy, right? To you need to run the car, you have required more energy, right? So that is not feasible. But if that, I mean, we easily can see understand about the aerospace because we are concerned about the weight over there, right? But in case of the road vehicles, that we are also concerned about the weight. If weight is high, but sometimes we cannot go very lightweight, because if when you are having the more speed, your vehicle is very less, then it will be run away by the ears, okay? So we have to design a component that must sustain on the road, so that must have sufficient weight as well. Okay, so I mean, this is just a balance. Okay, how we cannot make a a car of like plastics. Okay, that we can think about. Oh, they are having the less weight, but at the same time they are not having the strength. Okay, and at the same time when they are having the high speed, they will run away by the air. Right. That is not feasible. So everything is going to be consider going to be part of considerations when anything is going to be designed. Okay, so by seeing all the aspect of your designing or materials properties, accordingly we design the components. Okay, so high strength to the weight ratio that we get here, excellent machinability, allowing the further precise manufacturing. If they are having the good machinability, then we can precise exactly what the design that we are requiring, right? Because if they are not having the machinability properties good, then we cannot precise manufacturing. Okay, we could not have the if suppose we are having in a lab, and that we are designing on industry, that we need to design a component like a the exact 5 right? So how we can design? Okay, so we must have a machining capacity of that material must be high. If they are in that, then we can design any whatever the part that we require in. But if we are going in a very small part, and if the material is very ductile, sorry, brittle, then we cannot machine at that small level. So that is not a precise. Okay, this means whatever the exact dimension that we require, we can machine. That is known as precise manufacturing, and that will be possible when the material has you know good machinability, right? So good heat resistance. Good heat resistance means whatever the, I mean, the heat, uh, as we know that, I mean, when the material gets heat up to certain limit, they resist, but at a higher elevated temperature they can melt. If you cross or you can reach very near to that melting point, the material will get start melting. Okay, they will get soft first. Okay, melting point would be very at a very high temperature, but before that, your material will get soften, and the soften meal their strength is going to decrease, and we will consider as our material has, or our component has failed. Okay, so for that we must have a material which is going to be used as a component must having a good heat resistant. It depends on the application part. Okay, if you, I mean, the component which has been designed, that is not going to be used in the area where heat is high, then it's okay, fine. Then we don't consider the good heat resistance property in the material. But sometimes where heat is basically generated more, and the material or the component will experiences more heat. Okay, when they are in application part, then we must have to design that component with the material they are having more or good heat resistance properties. Like if we take an example of the IC engines, right? So what IC engines do, they are having the more temperature, especially when the the power stroke happens. Okay, when their ignition start, burning of fuel, that you can say, Well, at that time already we are having a air or a gas mixture, they are having at a very high pressure, high temperature, and all of a sudden during that high temperature and pressure the ignition start. So due to the ignition the temperature rises more. Okay, so if the material of that particular cylinder is not going to resist that particular temperature, it means they will burst. Okay, so for that, or they will melt, you can say anything. Okay, so for that we know we have to design a cylinder piston which must be of having good or high heat resistant. Though still we need to provide some coolant sometimes, or coolant means the lubric, the water or something which can reduce the temperature, from the outside. Okay, so that the temperature must be in control manner. Okay, so that we cannot, having a failed engines during service. Okay, so ability to undergo the heat treatment for the enhanced properties. So I have discussed at the beginning of this topic that aluminum copper alloy can be easily heated. Okay, so heat treatment can be done very easily, and due to the heat treatment, and if the heat treatment has been done, perfectly, then we can get the properties with the enhanced, way. So the property that we are going to get here, that would be of good. Okay, so a proper heat treatment, and according to what the kind of the property that we are going to change in the material, that must be followed the different heat treatments.